We're recording now. It's going.
You should record it.
Testing 1, 2, 3, 4. Humpty Dumpty. What about Humpty Dumpty? I told you my joke, right?
No, you're recording.
Humpty Dumpty had
That's 'cause you're
a
just
really
getting-
bad summer, but
Okay.
it's okay because he's going to have a great fall. I know, but I have to tell for the viewing audience.
Yeah, but we need a joke of the day.
All
We
right.
are the viewing audience.
What's the fact of the day?
The fact of the day, we gotta move on. Okay, so we're working here. I'll try to come up with another one in between. Maybe I'll. So we talked about sets. Here we go. Sets. There they are. So these are sets, types of sets. Whoops. Going back. Going back. 8 best friends. You can have a set made of your 8 best friends. Each friend is an element of the set. So each one of these things is called an element. Okay? So Alex is an element, Joe is an element, Casey, Drew, Tom, Hunter, Sam. They should be capitalized. Okay? So an element is one item in the set. Okay? Can I move on? Just remember that word element. Okay? An item in a set. Soccer. Now let's say that Alex, Casey, and Drew and Hunter play soccer. We can write the set soccer is Alex, Casey, and Drew. Moving on, can I move? Don't write everything down too much. Now let's say that Casey, Drew, and Jade play tennis. We can write the set as Casey, Drew, and Jade. So these are all the friends, right? And then finally, you can put their names in 2 separate sets like this. But friends who play soccer or play tennis, this is important, is called the union. Okay? A union is all the things, all the elements that are in either one set or another set. Okay? That's what a union is. Okay? How many people in here play a school sport? How many people in here play a musical instrument? Okay. How many people, raise your hand, how many people either play sports or play a musical instrument? Raise your hand. Play sports or, you don't play sports?
I play sports, but not an instrument.
Or, I said or. So if you play sports or you play, you raise your hand. Okay. How many people play sports and play a musical instrument? Raise your hand. 1, right? So that we'll get to next. But if you do either or, you are in the union, and the union is represented by this U-shaped symbol. How many of you have seen this before? Some of you, a few of you. Not. I know they teach it in middle school somewhat, but friends who play sports and play tennis are just Casey and Drew. So you could do that with a Venn diagram like this, where the union is everything in either set. The intersection is an upside down U, okay, or a curvy thing, and it's the people who do both, okay. This is the intersection of 2 sets, and that's called the Venn diagram. Anyone want to write that down, or you're good? Can I move on? Can I move on? Or do I have to be a minute? Intersection union. Okay then. Moving on. Which way does the U go? You go, think of them as cups. They used to have a car from Russia called, or Czechoslovakia. A Yugo. Anyone ever heard of a Yugo? It was a car. It was like, back in the 80s, it was this really small car, and everyone made jokes about it because it's like the worst possible car you could get. Like they rattled and they were really cheap. It was like a golf cart with a little engine in it. They were horrible. Yeah. Union. So think of a union as a cup, and it would hold more. An intersection, it would hold much more than something that's going upside down. So union is the one with more elements, and intersection is the one with less elements. So we just raise our hand. Like over half of the class either played a sport or did a musical instrument, and then only one person in the class. I can't believe that. Only one person does sports and a musical instrument? Really? You guys need to be more, you do. You play? Oh, okay. All right. Anyway, you guys need to be more well-rounded. All right. Okay. Moving on. Now, I think, what's next? We're going to do some practice. Union is or, is in either set, and intersection is in, and it's in both sets. Okay? So we have about 20 minutes. I'm going to pause here for station identification. Not really for station identification. Practice. I think that you're going to get some practice here. Whoops. There we go. Ready, set, practice. Ready, set, but then we're going to practice some more after this. Find this, the intersection of nice and bike. Intersection of nice and bike. What am I looking for? Oh. Intersection of nice and bike. I'm working. Okay, so if you did that, you should have done for our viewing audience, okay? Because people are going to watch this in their free time. The two elements are that, okay? Okay, the intersection of the, do this, find the answer to this. Moving on. So, a lot of people didn't get that right. So, it's everything that is in either this set or is in this set. So you would include the M, okay, because it's in both sets. So you include that. You don't exclude it if it's in both sets. So all the letters in Monarch, okay, plus what else? Plus what is in this set that's not in this set? And there's a T, right? That's what the union would look like. Because it's everything that's in either this set or in this set. Yeah? Okay?
Yes.
All right. Next, whoops. I am hungry. The intersection of I am hungry. Intersection, you can use this symbol. Keep going. So if there is no intersection, because there's no elements that they haven't done, I saw some of you using this, or you can use this. That means the empty set. Okay, this means the empty set. Some of you wrote NA. This is more mathematical, like that. Okay. All right. So now we're going to get into some more complicated stuff. I don't have any more PowerPoints on this, so I'm just going to bring up a piece of paper, okay? And the next thing is called, I gotta look in my notes for this, okay? These are called compound inequalities, okay? Am I still recording? Yeah. So compounded, let's get a better color. Red. Compounds. Compound inequalities are inequalities that you can have intersections and you can have unions. X greater than -3 and X less than 1. And graph, and what they'll say for this is graph and writes in set builder and interval notation. So I'll do a couple examples and then we're going to do some practice, okay? Notation. So the way you do this, we have already done x is greater than 3, right? How do I do x is greater than 3 on a number line? X is greater than -3. Curvy brackets or square brackets? Curvy or square? Curvy bracket, and then you go up this way, from negative 3, right? Now if I want to do x is less than 1, I'm going to start up here at 1, and I'm going to go down, right? This way. You understand that? X is less than 1. Where do these two things overlap? Where do those two things overlap? If x is less than 1 and x is greater than negative 3, how could I graph the overlap of those two things on a number line? Go ahead, Kate.
Bracket on both sides.
Bracket on both sides.
1, -3.
Perfect, okay, 1 and negative 3, and then squiggly line in between, right? This is your solution graph, right? To write that in interval notation, we've already done this. You guys remember? Curly bracket, negative 3, comma, 1. That's interval notation. Set builder, I know I'm kind of going fast, but set builder is just set builder. You would write bracket x bar, and then you would write x is greater than negative 3 and x is less than 1. That's your, so this is set builder here, this is interval, and this is the solution graph. All right? Yes? No? Maybe? And implies, the word and implies intersection. Intersect. So if you see the word and, that is an intersection of two sets. Can I move on to the next one? Hello? Yeah? Okay. So the next one, hopefully we'll have some time to practice short data. So the next one, whoops, what did I just do? Let's get a new piece of paper. There we go. So the next one involves or, okay? And so the next one says x is less than or equal to 1, negative 1, sorry, negative 1, or x is greater than 2. How would I graph that on a number line? Let's skip the two extra number lines. Let's just see if we could graph it straight ahead. Where would all the numbers bigger than 2 be? To the right of 2 or to the left of 2? To the right. So you put a little curvy bracket here at 2, okay? And then you go up from there, okay? Where would all the numbers less than or equal to negative 1 be? To the left of negative 1. Square bracket or curvy bracket?
Square.
Square bracket, like this. Whoops. That's not very good squiggle, but you get the idea, right? That says negative 1. Negative 1. Okay? And so if you see the word or, okay, that usually implies union. Okay? And to write this in interval notation, you write it just, you would go like this. Negative infinity up to negative 1, curvy bracket on this end, square bracket on this one, and then in between them you would put or, okay? And then x is greater than 2, you would go like this, 2 up to infinity, watch your mouth, okay? And you get this. Do you follow what I just did? This is interval notation. Set builder notation looks just like, kind of like the original problem, except you have to do brackets, x bar, and then you say x is less than negative 1, or x is greater than 2. So that's it. So if you see the word or, Usually it's going to be out here or down there. It could be here or there, okay? And or usually implies a union. Oh, I said that, okay? And and usually implies an intersection. You ready to try a couple? Okay, so your turn, okay? Your turn, here we go. Try this. Try solve and graph. Solve and graph. And give that a shot. What? Sorry. Word, sorry. But with this one, it's tricky because, right, the first thing said, if you solve this one, you get x is less than 2, right? So that's a curly bracket going this way down to 2, right? But this one, you solve them, what do you get? What do you get? X is less than or equal to what? -2. So if I start here at -2, that, oh, we're almost done, aren't we? It overlaps down this way. So your solution is this part of the graph. Anything that is less than -2. Your homework is just MathXL, okay? Just MathXL. I didn't get to everything, but you can get some help with the MathXL whiteboards. Please put the whiteboards away.